What's up, YouTube? It's been a while. I've had a bit of a break, gone on vacation. I'm back and I'm eager to start producing more videos. This one is a series of videos building up to some features in C#8, but you won't necessarily get the purpose or the reason for the feature unless I kind of build up this whole thing. So there'll be 2, maybe 3 videos prior to the actual C#8 feature. And I'm guessing as you hear some of these videos, you'll guess what the C#8 feature I'm talking about. There are many other C#8 features I'd like to talk about, but I want to start with this one because it needs a bit of a foundation. Now, the features that I'm going to be talking about are not part of C#8. They have actually been in C# for, I think, since C# 3.3.5. Okay, so they're old features, but most people either they probably use some of the things, but don't quite understand it. And in some cases, I'm guessing they don't use it at all, which is probably the next video. And certainly the vocabulary being used is not common. And as a result, I think that'll cause some confusion in the C#8 feature. So even though I'm saying C#8, this feature, this video is the Iterator pattern. It's been in C# since 3.5, I think, C# 3.5. And you don't need to use this you don't have to wait for C#8 to use this. You can use this today, potentially. All right, so what is the Iterator pattern? Of course, there's the definition of the pattern, but rather than give you a definition, I'm just going to show you because there's a feature in C#8, a language feature in C#8 that makes that really, really simple for us to create and use iterators. And that's the yield return keyword. I'm guessing a lot of you have used yield return sometimes without necessarily understanding how it's working or why or when you would or would not use the yield return versus the return. And so this video is going to try and clear up some of those things, but it's important to understand the yield return, the iterator pattern, because the next one is going to be talking about streaming, and streaming is not what you imagine. So again, I need to go into that video and talk to you about streaming. Maybe I combine the 2 videos into one, but if you don't see it in this video, it's going to be the next one. I'm trying to make these short videos, so if anyone wants to just understand what the iterator pattern is, what is C# streaming, and so on, rather than watching one big long video, you can watch these in the particular videos that you're interested in. All right. So now looking at the screen here, I've just got a simple .NET Core console application. It doesn't have to be .NET Core, but this is the code I've got so far. So I've got some variable called numbers and it says get numbers. I'm going to implement this. Oops. I'm going to implement this numbers, get numbers. Now the iterator pattern has a couple of requirements. So, it's a pattern. So there are certain things you need to do in the way you write code. One is the method that is returning the iterator must return an enumerable of t. So let's make that happen. Enumerable of, in this case, let's say it's ints. And then of course the numbers is an int. As you can see over here, t is an int. I can now for each this. And let's call it number in numbers. And print the number out to the console. Okay, I'm just going to keep this simple since the idea is just to show the iterator part and not build a full-out application here. Okay, so now when we have, what's this complaining about? For some reason I said equatable. I'm guessing I need to use link here. Since there's no link, it's not giving me that help. It's funny, it was brand new C#.NET Core console application. Well, it's been a while since I had to do that. Okay, so I have this method that returns an enumerable of int, and then this method uses that collection and then iterates over it and prints out the numbers to the console. Fairly simple. All right, the key thing is the implementation of this method here. So an iterator method needs to return an enumerable of t, all right? So you need to return something. Now this could be simply a list. You could have a variable, this is called list. Let's say is a new list of t. And you can add items to this list, but I can for here just return the list, all right? So this is valid because lists also implement the enumerable interface, but this is not the iterator pattern. The iterator pattern uses the yield return statement. So if I were to do something here, for example, if I were to use yield return, I could say yield return 0, and then I can say yield return 1, and yield return 2, and 3 and 4, 5, let's say, right? So I can have multiple yield return statements in my method, and this is now an iterator. Now you can't mix the yield return with return. A method can either use the return keyword or can use multiple yield return keywords. You cannot mix the two things. So when you're thinking in terms of an iterator, you're not confusing that with a collection or a sequence. Now the iterator pattern, and this you could for each in another collection. Let's say you had some sort of a collection in your hand, something, you could over here implement it as a yield return, right? So it could be returning in a loop. And we'll do this example in potentially the next video, which is the streaming part. I don't want to mix the two things, but they are completely different concepts and ideas. They are combined to some extent along with async await in the C#8 feature. All right. So you could do it like that. You could return whatever, let's say item, if item were an integer, right? You could return like this. This is going to complain since item is not an integer. So I'm going to take this out. The idea is basically you cannot confuse, you cannot mix both return and yield return in the same method. The method is either using yield returns or it's returning or it's using return. All right. Now, this may seem a little weird, but it's going to get a lot weirder, actually, in a nice way. This is when I first saw this feature, especially the debugging experience of this feature, my brain just went, whoa, this is deep. And it is deep. It is, I can't imagine how the Visual Studio team gives us that debugging experience, because it is, my brain just, fries up thinking about it. So I'm going to show you that, because that's going to explain to you how this thing is working. And then I'm going to talk about some of the do's or don'ts, the gotchas, when not to use the iterator pattern. All right. Okay. So first I'm going to put a breakpoint here. I'm going to put a breakpoint on the entry point of this method. I'm going to put a breakpoint on the first yield return, the second return, and the third return, just for the sake of showing you what's going to happen here. Now, when I run this application, you would expect the get numbers call to make the debugger stop here, and then eventually it'll come to the for each. Let's see if that assumption or thought that you have is true. Get ready to be surprised when you see the actual behavior. So it never stopped in the get numbers method. All right. It has for the first time stopped here on the for each statement. Now, those of you who are used to using LINQ, the deferred execution features of LINQ, then deferred execution of the deferred execution feature of LINQ uses the iterator pattern, and that's how it's being deferred. And I'm going to explain that to you. I'm going to explain what's happening behind the scenes to some extent, so you understand this feature. It's important to understand this feature to be able to move on to use streaming and to be able to move on to use the next C# Async Streams feature that we're going to be talking about in the third video. I might make all these videos today, tomorrow, the day after, whatever, so you don't have to wait for it. But I'm planning to split them up into 3 videos so they're not too long. Maybe it's 2 videos and not 3. Either ways, you'll know when you see the videos and the title. All right, so it stopped in the for each. It never actually stopped here on the first breakpoint. So it seems to have skipped this method. All right. Now when I step in here and it tries to use the numbers variable here, that is when it's trying to access the single number, that is for the first time when it comes and stops in this method. Isn't that weird? I mean, this is the coolest debugging experience. This is not necessarily how it's working, but this is how you want to think about it. Conceptually, this is how you want to understand what is going on behind the scenes with the iterator pattern. The iterator pattern is implemented with lots of compiler magic. If you remember the whole C# loading video I made a few months ago, I explained what happens when you compile your code. This is a lowering feature that produces the iterator pattern for you behind the scenes. You simply write code like this and the compiler produces gobs and gobs of code. So you do have to be careful of the fact that lots of code has been created on your behalf, giving you a simple syntax to write code like this, but it gets weirder. This is really cool. It's going to get weirder. Okay, so I step in here. It gets to the first yield return. In this case, it's going to return a 0. So of course, it's going to return, isn't it? So it comes back out here and gets the number. And for the first time now, the number is 0. So it's going to print that number out. You can see it's a 0. And then when it comes back to get the next number, it's going to jump to the third breakpoint. It never actually stopped at the first breakpoint. It never stopped at the second breakpoint. It actually stopped at the third breakpoint. Isn't that's like the weirdest thing. That looks like re-entering code, meaning the code is able to re-enter at specific points into your system in this method rather than coming in starting from the top. It appears like that. And that's how you want to think about it, because it came from the outer method, came in here, went back to the outside, came back to the inside, to this method, went back out, and it's going to go back out, and so on. That's how you want to think about conceptually how the iterator works, or how to think about basically the iterator pattern. That's not what's really going on, but that's how you want to think about it. Okay, so you return 1, it goes back to the caller again. Caller prints out that number. At this point, the number's value is 1. And then when it goes back to get the next number, it jumps straight away to the fourth breakpoint. That is just too cool. That is, man, if I were the person on the team, the debugger team trying to do this, my brain would have fried totally. I mean, I'm just imagining a really complicated way to contort the debugging experience from what's actually happening. So maybe simpler than it thinks, but than it seems to me. But this is mind-blowing shit. All right, so come back out and so on. So now that's to the extent that I want to show you the debugging experience. I hope you understood what's really going on. It seems to be going in and out of this iterator method, and the yield return is making that possible. If it was just a return, it would have returned once and for all, and that would have been that. But the key takeaway from here with the iterator pattern is it is returning to you as soon with the yield return is returning to the caller, the call site, as soon as a single data element is available. It's not waiting to accumulate the collection. Let's say we had 1,000 numbers returned from here. If you had to put this in a list, we would have to add all the numbers in a list and return a list, and that's fine. It'll work. It's not the iterator pattern. The signature won't need to change in this method because it could be returning an enumerable of int, but it's not the iterator pattern. If you were to implement this using the yield return, whether it's in a for each or single lines like this, it is returning a single data element to the call site, one element at a time, rather than having to accumulate all the data elements before it returns. And that is the key part of the iterator pattern. And that's also a key part of streaming, which you're going to be talking about in the next video. So that is also the key part about streaming. Or streaming is sort of based on off of the iterator pattern. All right. Now, before we finish with the iterator itself, there are some caveats you got to be aware of. All right. Let's look at what those caveats are. Let's say I've called this get numbers and I iterate over this collection once. And what if I were to iterate over this collection either here or somewhere beyond this point another time. I don't know why I got this here. Okay. Now, this is the part that you want to be. You need to understand this, and therefore, if you understand it, you know when to and when not to do certain things that I'll explain moving forward here. All right, so I'm leaving the breakpoints here so that you see what's going on. I'm also going to put breakpoints in the for each method like that. All right. Okay, so only I can remove these ones. I just leave the first year return and the entry point in the method here. All right, so I'm going to run this and let's see what happens. So of course we expect it to hit this breakpoint first before it comes into this method, right? And then it'll come to this method first once, and then it'll come in here again, and then it'll, since we remove the breakpoints, it won't stop there anymore. Let's come here. The next iteration through is come to 0. The next iteration through is come to this 1, and then it moves on, and now it's come to the for each. Now, this is where the thing you have to be careful about. It's still accessing the same numbers. It's not calling numbers again, right? It's like you already have the numbers in your hand and you're just iterating over it again. Watch what happens. It's gone back to this get numbers method and it's come back to the entry point, meaning it's restarting the iteration all over again. This is the part you want to be careful of. This, every time you iterate over some collection that was given to you by method returning an enumerable that is also implemented using the iterator pattern, then this is what's going to happen. It's going to execute that method multiple times. Now, they may not be what you want because what if that method is costly in terms of memory, in terms of performance. You don't want that method to be called multiple times. Maybe that method internally is going to a database. You don't want it to go call a database or an external service or what have you. So you have to be careful about these things. If the method is implemented using the iterator pattern, it is a deferred execution, just like the where clause in LINQ, and it'll be called multiple times each time you iterate over that collection. So if you plan to iterate over that collection that you were returned to by a method implemented using the yield return, you can do a to list on it. For example, what I mean by that is here. So let's say I say get numbers, and then I do a to list. All right. Now, when I do a to list, I'll just run the whole thing again. Hopefully remember what happened the first time around. So this time it's not stopped in the for each here. It's come into this method and it's going to stop on each of these yield returns, right? And when it returns out of here, it comes out. At this point, the numbers collection actually already has the values, the numbers. So this is not deferred execution anymore. So you have converted, and I'm sure you've seen some of this. If you're using EF, you tend to use the to list and things a lot, probably not knowing why, but this is what's going on. Internally, under the hood, those methods are implemented using an iQueryable or an iterator, and they are both deferred execution. So they will re-execute whatever it is that they're doing here in this method. If this method is doing this, it's just going to come back into this method over and over each time you start to iterate over that variable that you thought we already had in your hand, the numbers in this case. All right. So to eliminate that, if your method has been implemented using the iterator pattern and you want that to be that way, no harm in it, then in the cases where you are iterating over this return collection multiple times, you should use the to list here to materialize that collection rather than leaving it as a deferred execution. And then you will not pay the penalty, if you will, of calling or iterating over that collection multiple times. Iterators do come with an overhead. The code that the compiler generates in all of this is not simple code. It's got quite a bit of overhead in terms of code. So it's an internal state machine, and that is fairly complicated. That's not to say you shouldn't use it, but it comes at a certain price, but it comes with some benefits. If you look at the iterators all by themselves, the benefits are not quite obvious. Like, why would you want it? But in the next video on streaming, we will look at the benefit or one of the advantages or why streaming is such a good thing, and the name streaming and what it means. So I hope this has been useful. It's a short video, and I've intentionally kept this one short. I know some of you like the short ones, but this is just this topic, the iterator pattern. And in the next video, we're going to be talking about streaming, which is based off of the iterator pattern we just looked at. So if you like this video, please like. If you are not a subscriber and you come this far, please subscribe, and I will see you next time.